So we're going to roll a balanced green die and a balanced red die. So we're going to assume that they're fair die and that one side is not been weighted or anything. Okay, so we'll figure out A and B in a minute, but let's just list the sample space for this green and this red die. All right, so I'm going to assume the first one's green and the second one's red. We could have a 1 on the green die and a 1 on the red die. Or we could have a 2 on the green die and 1 on the red die. Or a 3 on the green die and a 1 on the red die, and so on. All the way up to a 6 on the green die and a 1 on the red die. Well, I could have a 2 on the green die and a 1 on the red die, or a 2 on the green die and a 2 on the red die, or a 2 on the green die. Oh, I'm sorry. I've been keeping the red die the same, so let's go 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. And you notice that I just sort of establish a pattern and keep that pattern up so that I list every single die. So the first one I kept my red die the same throughout, and the second one I kept my red die the same throughout. Now let's go to the red die being a 3. So a 2 and a 3, a 3 and a 3, a 4 and a 3, a 5 and a 3, a 6 and a 3. Now let's go to the red die being a 4, so a 1 and a 4, a 2 and a 4. And you notice I'm going through each the possibilities on the green die. A 5 and a 4 and a 6 and a 4. And now let's make the red die a 5. So 1 and a 5, a 2 and a 5, a 3 and a 5, a 4 and a 5, a 5 and a 5, and a 6 and a 5. And then lastly, let's make the red die a 6. And it would be nice if I could type correctly. Let me fix that. 6 and a 5 is what that should say. All right, and then finally making the red die a 6, we'll have a 1 and a 6, a 2 and a 6, a 3 and a 6, and so forth. And now I've listed all 36 possibilities. And if we think there's 6 possibilities in the green die times 6 possibilities on the red die, there's 36 possible things. And that's what we have here. All right, so let's take a look at our events. A is the event that the sum of the dice is 7. So let's look for where the sum of the dice, where the 2 die add up to 7. All right, so if I look down here, let's see, this adds to 7, this adds to 7, this one adds to 7, this one does, this one does, and this one does. And if we check, that's the only ones. There are 6 of them, so this is 6 out of 36, our entire number of outcomes. All right, now B is the possibility that both numbers are less than 4. All right, now I'm going to change my colors and we'll see why in just a minute, but both numbers are less than 4. All right, so let's see where both numbers are less than 4. Both of them are less than 4 here. Now here one of them is 4, so we don't want that one, but we want less than 4. Both numbers less than 4, that's believe that's it. Everything else has a number that is 4 or more. Oh, I'm sorry, less than or equal to. So let's get the 4s. I needed to look at that equal sign. Not that one. That 5 is greater than 4. I believe we now have all of them. All right, so let's notice this is 4 by 4. There's 16 of them that I have circled in purple. So this is 16 out of 36. Now we can reduce both of these fractions if we want to. And when we're doing answers on a test, we certainly should. All right, so this one reduces to 1 over 6. And this one, let's see, 4 will go into the top 4 times and into the bottom 9 times. So it's 4/9. All right, now the probability of A complement. Let's remember that A was the green stuff, and the complement is everything but that green stuff. So there were 6 of these green entries here. That means that there are 30 that are not green. Remember, there's 36 total here. All right, so this is 30 out of 36. Or we can reduce that to 5 over 6. All right, now B complement. That's what our little line over B means, is everything but B. So everything but the purple down here. Well, there were 16 of these purple. And if we think that there's 20 left over out of the 36 that are not purple here, so this will be 20 out of 36. Which reduces to, let's see, 4 goes into the top 5 times and 4 goes into the bottom 9 times. All right, now I'm going to try to put some spaces in here just because I'm running close together. All right, so the probability of A and B. When we look at A and B, we want where both events are happening at the same time. So if we're looking down here, we want where the colors are both there together. And let's notice there's green and purple right here, and there's green and purple together right here. So there's 2 of them out of our 36. Or if we reduce that, that's 1 over 18. Now, the probability of A or B, we count up everything that is purple and everything that is green. But we don't want to count things twice. So if it's both purple and green, we're not going to count it more than once. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, who are both green and purple out of 36. And if we reduce that, 4 goes into the top 5 times and into the bottom 9 times. All right, now the probability of A given B. We have to use one of the formulas that we got in the slides. And the formula for the probability of A given B is the probability of A and B over the probability of the second one in the notation, the probability of B. Okay, so let's just go back to previous answers. And I'm actually going to go back to the non-reduced fraction. The probability of A and B we got right here was 2 over 36. And the probability of B was back here. It was 16 over 36. Now, why did I go back to the non-reduced fractions? Well, the reason for that, 2 over 36 divided by 16 over 36. I'm just going to go down here for a second. 2 over 36 divided by 16 over 36. Remember, your rule for doing division of fractions is to flip the second fraction and then multiply. So 2 over 36 times 36 over 16. And then we can cross cancel the 36. We also can cross cancel with the 2 and the 16. 2 goes into itself once and into 16 8 times, which gives us 1 over 8. Now the shortcut is up here, if we notice these two denominators are the same, then we can just think of them as canceling out ahead of time, and we get 2 over 16, which reduces to 1 over 8. So it's a good idea to keep the non-reduced fractions when you go to these steps and save yourself a little time with the shortcut. All right, now we still have 8 to do. I'm going to put some space in here. And it's the same formula, but this time we want the probability of A and B on top. But the second one in the notation is A, so it's the probability of A on the bottom. Now again, I will use the non-reduced fractions. So the probability of A and B was 2 over 36. And then the probability of A, let's just go back up and grab it, was 6 over 36. Remember, I'm grabbing the non-reduced part. And now if we just think of those 36s as canceling, we get 2 over 6, which reduces to 1/3. And there we have it.